What's that? All right. So this question, so yesterday we talked about if I'm going to dilate around 0, 0, all I've got to do is multiply the x values and the y values by how much they want me to dilate, right? And it gives you my new points, okay? We can't do that if we want to go around or dilate around or about a point other than 0, 0, okay? Because when we start at 0, 0 and we start to look at like corresponding points from the image and pre-image, because your starting point is 0, 0, you get, because subtracting 0 is a really nice thing to have, you end up with a relation that shows you that the scale factor that you get from dividing corresponding sides is identical to the factor that they provided you, okay? That doesn't happen when we go around the point 2, 3, or anywhere else in the coordinate plane. So what we have to do is it's a process that actually kind of fools the system, okay? What we're going to do is we're going to take I usually use a different color to do this to help me organize my work and realize what I'm really doing here. We're going to take and draw a new axis, okay? A lot of times you hear me call it a pseudo axis. You guys know what the prefix pseudo means? Huh? Anybody ever heard of somebody that has a pseudo illness or a pseudo injury? Not small, not big. Fake. Okay. So it's not real. Okay. So this is a pseudo axis. It's not the real axis. Okay, but it's going to play that role for a moment. Okay. So if I make this 0, 0, does that kind of make sense? Yesterday I talked about like taking a transparency, and on that transparency having an x and y axis graphed on it, and then I shift that origin of that transparency to this point right here, and now these other points A, B, and C are going to have different ordered pairs. Okay, so let's take a look at this real quick. If I call this 0, 0 now, how do I get to A from that point right there? If it's 0, 0, you go which direction first? If I'm going from this point right here to A, but if I'm in the x and y coordinate, usually you move left or right first, right? So we're going to go left 1 and then down 3, right? So I'm going to rename this point here -1, -3. Okay. Well, let's fix this. Let's go 3, 2. Thank you. 3, 2. All right, so if I want, thank you. If I want to dilate around 3, 2, so let's rename that. Okay. But I'm making 3, 2 now the origin is 0, 0. To get to A from now this new 0, 0, this pseudo origin, I'm going to move left 1, down 3, correct? Okay. How would I go to B? Do I go left or right any? Nope. So it'd be 0 in the horizontal direction, right? But now I'm going to go down 1, 2, 3, 4, 5. And now to get to C, I'm going to go left 1, 2, 3, 4, 5, 6, 7, and then down 4. So left 7, down 4. So I'm going to rename these as, I'm not going to call them A prime or anything. I'm just going to say A still. I'm going to do it in red, B in red, C in red. This point would be -1, -3. This would be 0, -5. This is -7, -4. Now here's my question. You could do this with a picture, but how could I get these points just by looking at that ordered pair and that ordered pair? If I take this one and subtract that one, don't I get that? 2 minus 3 gives me -1. -1 minus 2 gives me -3, right? 3 minus 3 gives me this 0. -3 minus 2 gives me -5, right? -4 minus 3 gives me -7. -2 minus 2 gives me -4. Okay? So that process was original point minus point of dilation. Okay, that will give me this red column there. Okay, now these are now points that are based off of a 0, 0. So if I want to dilate this thing now because these are based off of 0, 0, we can now multiply. Okay, so now what I'm going to do is multiply each of these by 2. So -1 times 2 gives me -2. -3 times 2 gives me -6. 0 gives me times -2, or times 2 gives me 0. This is going to give me -10. It's going to be -14 and -8. Is everybody okay with that? Just multiplying these by 2 then. So you take your original point, subtract your point of dilation, then apply the dilation factor, which in this case was 2. Okay. Now, if I plotted those points, okay, off of this thing right here. So let's go ahead and go. I'm not going to have enough room to plot all of them because it's -14, -8, 1. But if I go negative from this point here, -2, down 6. 1, 2, 3, 4, 5, 6. Should be right there. Okay. So I'm going to call that A prime right now. Okay, so that would have been, that parallels back to this A here. Okay, so I went left 2, down 1, 2, 3, 4, 5, 6. Okay, if I go all the way down -10, so 0, -10, plot that point. 0, -10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, -10 would be maybe there. Okay, so that would be, I'm going to call that B prime for the moment. And then C is going to be at -14, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that's 12, 13, 14 would be about right there, and then down 8. So 1, 2, 3, 4, 5, 6, 7, 8. If I were to graph, so that would be C prime. If I were to graph these points and connect them with my triangle, okay, does the relationship that we created yesterday, we talked about yesterday, where if I draw through that point and that point, because those correspond, right, that a line will go back through my point of dilation. If I go through this point to that point, it will go back through the point of dilation. and this will go back through the point of dilation, right? We remember talking about that yesterday? Okay. So we have now placed our image in the right appropriate spot, but our ordered pairs are not listed right now. These ordered pairs right here are not based off of the original origin, right? The real origin, they're based off this pseudo origin. So the way you can find these ordered pairs is either to just go back to, okay, well, this was the real origin right there. And if I wanted to start at the real origin and find this point A prime, it'd be to the right one and then down 1, 2, 3, 4. So 1, -4. I know this is getting messy, but 1, -4 would be what that point turns into. 1, -4. Okay, this point B prime off of the original origin would have been 1 to the right, 2, 3, and then down 1, 2, 3, 4, 5, 6, 7, 8. So 3, -8. And now this point here would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then down 1, 2, 3, 4, 5, 6. So -11, -6. And that then is my image, my final image, and this was my pre-image. Okay, now just real quick, how can I go from these numbers here to these numbers if I look at that? Add them back in, right? You remember we took them out originally, right? We took the original points minus the point of dilation, applied the dilation factor, and now we're going to add back in the point of dilation. If I take 3 and add to -2, I get that 1. Take 2 and add it to -6, I get -4. If I take 3 and add it to 0, I get 3. If I take 2 and add to -10, I get -8. 3 plus -14 gives me -11. And 2 plus -8 gives me -6. Does that make sense to everybody? Okay. Now, so those are the order pairs, and that's the process you go through. Now, when I do these, very rarely will I draw this picture. Maybe one time in front of me would be nice, but I use this thing all the time right here. Take my original point, subtract the point of rotation, apply my scale factor, add back in the point of dilation. Say it again. You just multiply. So if the dilation is happening around 0, 0, all you do is multiply by the scale factor. So you take your ordered pairs and multiply them by, in that case, 2. And so that's an easy thing to do. If I didn't have this tool here, I'd have to have a new rule of what do I multiply by if I want to dilate around 3.2. What do I multiply by if I want to dilate around 5.2? What do I multiply by if I want to dilate around 7.2? Okay, so if I didn't have this tool, I'd have an infinite number of basically rules that I would have to know to dilate around any point possible. Does that make sense? Or if we use this approach here, it allows me to use the rule about dilating about the origin, and that's it. Okay, but I have to subtract that point of dilation out and then add it back in. Is that okay? So I want to show you, I should just structure this on GeoGebra real quick, just to convince you that what we're doing there is not made up. So we go A is equal to 2, -1. B is at 3, -3. C is at -4, -2. Okay. And then our point P for the dilation was at 3.2, we said. So the nice thing about GeoGebra is, or one of the nice things, is that it will allow me to just choose a shape, choose the point I want to dilate around or about, and it does exactly what we just did in the background. Okay, so I'm going to take, so it says I got to select the object, so I want that object there, and then the center of dilation, so P, and then type in my scale factor, 2, hit OK. And so give me these points A prime, B prime, and C prime. Well, let's go look at the algebra view here of what A prime, B prime, and C prime are. Well, that's exactly what we came up with by hand. Okay. So every single time that you do a dilation, that is going to be the approach that you're going to want to use. Okay. So in practicing this, let's just take the idea. I think it's cleaner if we just take a segment and dilate a segment. If you can do it with 2 points, you can do it with 3 points, 4 points, so forth. And that's why a lot of your questions in your homework, when you're doing reflections or whatever, they ask you only to do 1 point for a reflection, because they're on the assumption that if you can do it with 1 point, you can do it with 2. If you can do it with 2, you can do it with 3. Does that kind of make sense? So let's take a point at, let's call that A at 2, 3. Not 2, 3, 3. I'm having trouble with my coordinates today. 3, -2. And let's put B down here at 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So -4, -6. Okay. And it doesn't have to be the scale. But we're going to take that segment and dilate it. Okay. Somebody give me a number. 6 and 12. So let's go. Let's go negative. Let's put our point at -12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and up 6. 1, 2, 3, 4, 5, 6. So let's put our point of dilation at -12, 6. Okay. Give me another number. Okay, so we're going to dilate this by a factor of 4. Okay, now just bear with me here. Okay, if we were to draw this out by hand, if we had this graph paper in front of us, the numbers that I've chosen here are just, they're going to ultimately be too big for us. We'll exhaust all of our resources on our graph paper, all the size, the length and width of our graph paper. Okay. So what I want to do here is go through and see, can we apply the formula that we wrote above to help do this? Okay. So what we're going to do, all right, is we're going to start with our original points. So our original points were A at 3, -2, and B at -4, -6. Okay. We're going to then subtract out the point of dilation. Okay, with everybody? Just be careful when you do that subtraction, because I'm going to take, remember what we did in the previous one. Where'd it go? We did original minus the point of dilation, right? So when we come down to our example, original minus the point of dilation, it's going to be 3 minus -12. What's 3 minus -12? 15. What's -2 minus 6? -8, right? Okay. What is negative 4 minus negative 12? 8, right? Negative 4 minus negative 12. That's negative 4 plus 12. It'll be positive 8. And now negative 6 minus 6. Be negative 12, right? Now let's just see if that worked. I don't anticipate maybe you being able to count on your screen. Or I guess you don't have a screen, your paper. You probably didn't make things all that accurate in terms of your scale, because that's hard to do without graph paper. But if that was my pseudo origin, if that was redefined as 0, 0, is this point A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15? Is it 15 units away from point P to the right? And then it's down 1, 2, 3, 4, 5, 6, 7, 8 units, right? And that's what that 15, negative 8 is telling me. It's essentially telling me how far away in both directions are we from point P. And if we do the same thing, we can see 1, 2, 3, 4, 5, 6, 7, 8. And then down, this will be down 6, 7, 8, 9, 10, 11, 12. So right 8 down 12 gives me that point there. Does that make sense? I'll call that A for whatever reason, but it's B. Okay. So now we can apply the dilation factor, which says that A is going to, you said your factor you wanted to be 4, right? So what's 15 times 4? 60. What's negative 8 times 4? Negative 32. And then B, so 8 times 4 is positive 32, and negative 12 times 4 is negative 48, right? Okay. Would anybody want to graph those points? No, because you're going to run out of paper, right? Or if you're making your own graph paper, it's going to be a pain in the butt. So what I'm hoping to show you here with this is the necessity of a formula. Okay. If we don't have a formula, these things can be very time-consuming and resource costly. So now we're going to add back in the point of dilation. Okay, so we're going to start with 60 and add back in negative 12. So what's 60 plus negative 12? 48. What's negative 32 plus 6? Negative 26. And then 32 plus adding back in negative 12 will give me, what, 20? And then negative 48 plus the 6 back in will give me negative 42, right? So let's see if GeoGebra agrees with that. I think it's always appropriate to, whether we use GeoGebra or I think you could do some of this stuff in Desmos, to see if all that work that we've done, did we do it right? Okay. So our point was, say P was negative 12, 6. A was located at 3, negative 2, and B was located at negative 4, negative 6. Yes. Because we subtracted it out at the beginning. So when we subtracted it out, we were making this, we were taking this origin and which is the real origin, but we were making this the real origin. So then everything was defined. So all these points then got redefined. When we make them those two, they're redefined based on this point being the origin. But the final answer doesn't know that we did that. So we need to go back and say, well, this is really the true origin. So we need that movement that we took from the left and up, we got to put back in at the end through addition. So our dilation factor was 4. So I just took these ordered pairs and multiplied them by 4. So these ordered pairs are now the ordered pairs based off of about this being 0, 0. So then you can apply the dilation factor to those. So once we have this right here, all I'm going to do is say I want this to dilate. So we'll dilate that from point P by a scale factor of 4. And we should be looking at then A prime and B prime. Are those exactly the same coordinates that we came up with? 48, negative 26, and 20, negative 42. Kind of makes sense? Okay. In the past, I've shown students the ability to use Excel. You guys ever use Excel? Okay, so I'll just show you. You don't have to use it, but I think it's a benefit to be able to know. Like a lot of people use Excel just to, like, they write names here, they write a roster, and they'll put some characteristic of those people, and they'll automatically fill those things in. We can use Excel is a giant calculator. Okay, so what I want to do here, I just want to type in. I'm going to just say that this is the x coordinate. We'll put a comma, and then I'll say that this is the y coordinate, and we'll just use. So we'll say our first point that we said was, and actually let's do it this way. Let's cut that out. Put B in there. Let's call it. So this was point A. This was point B. Actually cut those out and put them there. All right. So our point A that we were working on was 3, negative 2, right? Just put 3 there, negative 2 there, and I'll put negative 4 and negative 6 there. That kind of makes those are the ordered pairs for point A, ordered pair for point B. Is that okay with everybody? Okay. I'm going to write over here in this one, say our point of dilation. So our point of dilation, the x-coordinate was negative 12, and the y-coordinate was 6, right? So I'm going to do that. Now what we can do is we can, let's do this. Let's put our scale factor, our dilation factor, and I'll just put it right here. We'll say it was 4. Okay. So now what I'm going to do with Excel is I'm going to ask it to take this stuff here and do exactly what we just did by hand. So if you remember, we took our original value, so our original x value from, let's say, point A. So I'm going to put equals parentheses, I grab that number, okay? So now what this does is it's going to say, well, whatever, it says B2, and that's whatever is in that cell. Does that make sense? So I can change this if I want to eventually, okay? And we're going to subtract out that thing there. Okay, and that should give me the 15 that we saw previously, right? Then I'm going to do the same thing with this. I'm going to take the original minus then that. It gives me that, right? That makes sense to everybody? Now we can do the same. I'm just going to do this with the 1 point, and I'll show you how I can then adjust it to get this other one if we want to. So then we take those two, and we apply our scale factor. So I'll take that cell and multiply it by 4. Now I said 4, but let's do it this way. Instead of 4, let's say that we're going to use that cell. And I'll show you why I'm using cells instead here in a moment. So those were two numbers we got, right? After we dilated. But then we needed to add back in, oh, not that, it was that, so it was E2. We need to add that back in, right? And then we needed to take this and add that back in. Now, does that give me 48 negative 26? That was one of our points, right? 48 negative 26? Okay. So this is my final point. Okay, final point. And we would, if we were really doing this intentionally, we would clean this up a little bit. But let's look at what this does, okay? It allows me to say, okay, if this was point A, was at 3 negative 2, let's take point B, which point B was, we chose it to be at negative 4, negative 6, right? So I'm going to type in negative 4, negative 6, and you see how everything changes? And now we get 20, negative 42, which was the B prime point. Does that make sense? Okay. If you were giving me a different scale factor, if you said I want a scale factor of 5, see how it changes? And now that would be the point, okay, that started at negative 4, negative 6, dilated about negative 12.6 by a scale factor of 5. Okay. Let's make this 0, 0 real quick and see if this makes sense, if this works. If you took that number, that order pair right there, and dilated about 0, 0 by a factor of 5, does it give you that right there? Okay. So Excel is a program, in a lot of these transformations that we do, Excel is a tool that we could program with our rules that we just plug in the points, maybe the movements or dilations or rotations, and it calculates it for us. The reason I show you that is because that is exactly what GeoGebra is doing when I click on this button here and say I want to select that. Okay, so what it does right there is it captures the ordered pairs for A and B. And in the background where you guys can't see it, it's in the coding, but it captures those ordered pairs for A and B. Okay, and then when I click on point P, okay, so let me go back. So I capture that, click on point P. So when I clicked on point P, now in the background what it's doing, and so there's a if-then command in the background that says if the user selects AB, capture AB, then if user clicks a point, capture that point, and now in the background do the subtraction between B and that point P, and then do the subtraction with A and the point P, and record what those differences are. Then this will pop up. When user types in 4, take those differences, multiply them by 4, and then add back in point P, and it gives me exactly what we want. Spit it back out visually. Does that kind of make sense? So that's how programs like this are written. You don't see all the manipulation happening in the background, okay? But that's what's going on when we are choosing things with our cursor and that kind of stuff. Okay, you can do a lot of neat stuff with Excel if you understand that. You can do a lot of neat stuff with GeoGebra if you understand Excel. Now, I'm not going to, I'm not going to ask you. They're not going to ask you on end of course exam. I would be very surprised if the end of course exam asked you to do something like that. I'm not saying it's outside the possibilities. If I were a betting person, I would say probably not. Okay, but I wanted you to see it just in case. And people always ask, well, why can I only rotate or dilate around 0, 0? There's other options. Okay, and that is the other options. Does that kind of make sense? All right, we'll stop there today. No new homework. Tomorrow.